Hey guys, welcome back. We're still talking about the fundamental theorem of calculus, and I will tell you that I'm just going to handpick just a couple of examples just to talk about for these problems. For question number 12, it says, what is wrong with the following calculation? I like this question quite a bit, and just to knock it out to save time here. So this actual calculation is correct. However, you can't solve this interval. This interval is not doable because if you look at the function 1 over x squared, if you look over 1 over x squared, you're going to get the function that looks like this. And so it's kind of important, actually, ladies and gentlemen, to think about it. If I were to ask you guys to find the area under the curve or the total change of this function on the interval from -1 to 3, well, look what's happening here. It's not continuous. It's not continuous at x equals 0, right? There's actually an asymptote there. So we're not continuous over this interval, over the interval from -1 to 3. So you can't solve it. It's just not doable. You can't do it. So even though this looks right, it's not right because you just can't solve it in the first place. So just pay attention to these problems and make sure that before you do the problem, and 99 times out of 100, it's going to be fine. But you just make sure that 1 out of 100 times that this is a doable problem. Okay? And for question number 13, it says it's so important. Yeah, it is, but it's just nice to know that what the fundamental theorem of calculus is. It really is just the fundamental theorem of calculus is what you're going to see for this problem. So I'm not worried too much about that for this problem. Let's look at number 15. So number 15 is the next one I want to talk about. And so for this problem right here, you want to look at x squared minus 1 over x plus 2. Again, it's undefined only at x equals -1, so we're good with that. So this one's very straightforward, ladies and gentlemen. Sometimes if you can't just simplify it normally, then you want to use algebra, right? So we're going to use algebra for this problem because we want to be able to integrate this, and we can't split the numerator, right? Because we have two things in our denominator. So we can use some algebra. So again, this is just another way of me having you guys rewrite, right? Rewrite. So I'm going to go ahead and cancel out these problems right here, and then I'm going to be left with the integration from 1 to 2 of just x minus 1 dx. This becomes a really easy question to do then, right? So it's just x squared over 2 minus x, and we're going to evaluate that from 1 to 2. So we're going to go ahead and plug in 2 first. 2 squared is 4. 4 divided by 2 is 2. Minus 2, well, there we go. That's great. Minus, and then we're going to plug in 1. So we're going to get 1/2, parentheses, 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 1/2 minus 1. And so we're going to get that this is going to be equal to 0 minus a -1/2. So this answer is going to give us a positive 1/2. So this answer is going to be A. This answer is going to be A. So a really easy question to do. Let's continue on with one at the bottom, number 16. It's telling us to find K. It's telling us to find K. So we're going to integrate this normally. All right. So this is actually not too bad of a question. We're going to get 8. The integration of x to the 7th is x to the 8 over 8. And then remember, K is a number. As you guys clearly can see here, K is a number, so the integration of K would just be Kx. And we're going to evaluate that from -2 to 2, and we're going to get that that equals 16. What's beautiful about this and why I like this question so much, ladies and gentlemen, is that if we go ahead and start plugging in, so we're going to plug in 2 first, right? We're going to go ahead and plug in 2. So this is when x equals 2. We're going to get 2 to the 8 over 8. Okay, and notice I'm not simplifying that, and hear me out here in a second. Plus 2k, we don't know what the k is, so 2k, minus, now I'm going to plug in -2. Well, -2 to the 8 is the same thing as positive 2 to the 8, so it's just going to be 2 to the 8 over 8, and yes, I'll put the negative here, so yeah, but it's going to be the same thing, and then it's going to be minus 2k, and again, that's going to be equal to 16. Well, the beautiful thing about this problem, ladies and gentlemen, is that if we were to distribute this, this is a positive value, right? This becomes a positive 2. So if I do this and distribute the negative, these two terms are actually going to cancel out. So if it's a calculated question, non-calculated question, which you guys can see it was because it's question number 24, then that makes sense. It's not, you're not going to have to do some crazy 2 to 8. If it's not bad to do, 2, 4, 8, 16, 32, count them on your fingers, etc. So it's not unbearable to do. And this is 2 to the 3rd. So this is really just 2 to the 5th. So really it's not horrible, but sometimes it's just nice to have that strategy. And so I'm going to go ahead and do 2k, and then I'm going to do minus a negative, so it's going to be plus 2k, it's going to be equal to 16, and now we're back to pre-algebra with this problem. And so we get k is equal to 4. So this answer is going to be 4. Okay? Okay, so for question number 17, I like this one a lot. I'm not in love with it, but I like it because it is a very long question to do, so I don't think it's one that's going to be testable. But it asks you guys, given the graph right here, and here's our function, and we're going to get to this in a second because we're going to talk about the fundamental theorem of calculus part 2 here in a minute, well, in the next video, what to do with this question. But it says, which of the following is the greatest? So all you're going to be doing here is you're going to be plugging in. So g of negative 4 is going to be equal to, so since x is negative 4, this is going to be where we're going to plug in negative 4. So it's going to be 1 to negative 4 of f of t dt. So this is just a gateway to compare g of x with f of x. So g is actually the antiderivative of f, right? If you look at our problem here. One of the things we'll say really quickly about this problem is the fact that if we have 1 and negative 4, remember we want this to be the highest number, so it's easier for us to solve. So we're going to go ahead and do our trick again, that we're going to pull out a negative, and we're going to have a negative 4 here, and we're going to have a 1 here of our function, and then all we have to do is find the area under the curve from negative 4 all the way to positive 1. Now, I want to say something really quickly about this problem is if you guys look at this part right here, you can see that this goes to 3, and then this also goes to 3. So these areas actually cancel each other out. So I don't really need to find that. Now, you could find the area of this triangle and find the area of this triangle, and that's totally fine, and you can actually do this minus this. That's legit, but these areas cancel out. So if I really want to find what this value of this is, I can actually just find the integration from negative 2 to 1, this triangle right here. So this is just going to be 1/2. This is going to be 1, 2, 3. And this is going to be negative 3. And so this is going to end up being equal to 9 over 2, right? 9 over 2. So that's how we get that first part. So A is going to be 9/2. And that's basically, without wasting a lot of time, ladies and gentlemen, that's how you're going to do these problems. So if we look at the next problem, or the next g of negative 3, we're going to look at, again, we're going to get 1 negative 3 of f of t dt. And so we're going to pull out a negative. That way we can flip them very easily. And then I want to go from negative 3 to 1, right? So now I want to find the area of this triangle. So negative 3 to 1 is this one. So this is going to be negative, because again, with the negative, it's going to be 1/2, and then it's going to be 1, 2, 3, 4. Again, negative 3. So this is going to end up being positive 6. Okay, positive 6. I'm going to just do one more quick one here. So g of 1, I love this one because if you plug in 1 here, and this is a property that I think you've talked about before, but if not, this is a great point to talk about it. So g of 1 is from 1 to 1. So guys, it's 1 to 1. It's right here. There's nothing. You can't go anywhere. We're not doing anything with this. So we're integrating from a to a. It's always going to be 0. It's always going to be 0. And then if we were to go and do the rest of them, so g of 4 would just be from 1 to 4. So it'd be the area of the triangle from here to here, right? So g of 4 is actually just going to end up being 3. And then finally, if we look at g of 5, it's going to be actually smaller because it's going to be from 1 to 5. So we're actually going to be losing, again, these two triangles go away. So it's just the area of this triangle right here, which is going to end up being 2. So this final answer that we're going to have is going to be actually B. B is going to be our biggest value at 6. Okay, so it's just area under the curve. All right, guys, I just got 2 more that I want to just highlight in these note sets. I know there's a lot of them going on here. Question 18, 19, 20, they're all the same question. And so I'm just going to I chose to do question number 19. These are calculator questions. So I just want to preface by saying that all of these are calculator questions, and you can always tell that based on the number that's up here. That's the 89th question. So it says f is the antiderivative of x squared over 1 plus x to the 5th, such that f of 1 equals 0, then what is f of 4? So if I were to integrate from 1 to 4 of this function, right? If I were to integrate this function from 1 to 4, I'm going to get, since it's the antiderivative of f, I'm going to get f of 4 minus f of 1. And so this is our fundamental theorem of calculus. I can use my calculator to find this value, right? Find this value. But more specifically, I can say that f of 4, and this is going to preface of what we're going to do next lesson, is I can move this f of 1 over, and I can get it like this. And so we're going to get to this in the next lesson. This is called the total change theorem. So it's just the fundamental theorem of calculus rewritten. Is that my final position is equal to my initial plus my rate of change, or my total change, And so you use a calculator for this, and then this is just 0. So that's actually super, super boring. So when you plug it into your calculator, you're going to get the answer is D. And that's exactly what you do for the rest of these questions. Okay, so it's not too horrible for that. So just remember, if you're trying to figure out, given f of 1 equals this, what's f of 4, or whatever these values are, if you integrate this, you're going to get an equation where you're given this f of 1 minus f of 4 minus f of 1. Okay. Okay, for question number 21, again, this is a calculator question, but we don't need the calculator. Well, we do need a calculator for this question. And it says, on the interval from 0 to pi over 2, and the area under the curve is equal to y equals cosine of x from x equals k to pi over 2, and we're telling you it's 0.1. So even though we're given the interval from 0 to pi over 2, it's telling us that the area under the curve from k to pi over 2 of cosine of x dx, it's equal to 0.1. And we want to figure out what k is. Okay, what k is. So the first thing we're going to do is we're going to integrate cosine. Well, integrating cosine is going to be sine of x. We haven't really talked about that yet, but it's just going backwards. What's the derivative of cosine? Well, that'd be sine. And we're going to evaluate that from k to pi over 2, and that's going to give us 0.1. All right, so I chose this example because it's actually not too horrible, but just one extra step we need to do at the end that you guys all know, but whatever. So we get that sine of pi over 2 minus sine of k equals 0.1. The sine of pi over 2 is 1, right? So we're going to get 1 minus the sine of k equals 0.1. If I move the sine of k to the right, then I get, and I do this to the left, I'm going to get 0.9. And so guys, I know you know this, but again, when I was going through the questions here, I want to just make sure you guys know that in order to find the theta k, you have to use the inverse trig of and that's why you need the calculator. So the inverse trig of this function, so the arc sine of 0.9, and you're going to get that this is approximately equal to 1.120. Okay, I know I said I only had one question left, but I want to do one more with you. But that's how you do that question. I was just looking at it really quickly, and I'm like, yeah, I want to show that to them. That, yeah, in order to find theta, you have to use the inverse sign, which again, BC students, you guys know this, but yeah, it's all good. All right, one more question. So this question right here, it says find the area of the shaded region on the interval from 0 to 2, and this is given by two functions. Again, this is pretty straightforward. I'm not going to do the question for you, but I just want to set it up. So I want to find the area of this region first because my upper bound is actually x squared, and I want to then change it and do another one here where my upper bound is x minus 2. So this is quite simple. You go from 0 to 1, and it's just going to be your upper bound, and technically, ladies and gentlemen, it's going to be x squared minus 0. You guys will truly understand that when we literally look at area, but it's just going to be your upper bound, so x squared and then dx for this, and that's going to give us this part right here. And then simply, I'm going to now find this area, but again, my upper bound is 2 minus x, so it's going to be plus the interval from 1 to 2 of 2 minus x dx. And you're going to just integrate these and then plug in, and again, eventually you're going to get the answer as 5 or 6. One thing that I would maybe not expect that I give you on this, for BC, is what this point is. So you obviously would not be getting this, nor this, nor this. You're just going to be given this graph. So how do we find this? How do we know what the 1 is? And then how do we know what the 2 is? Well, this is pretty easy to do, ladies and gentlemen, all right, and here's why. So in order to find this, right, our y value is 0. So you just say 0 equals 2 minus x. So x is going to be equal to 2. So that's how you find that one, because the y value of this function is at 0. And then how you find that function right there, this right here, well, you set them equal to each other. You set the two functions equal to each other because this is an intersection point of these two lines. And so you're going to get x squared. I apologize. That's supposed to be 2 minus x, by the way. So you were to go and do this and then start factoring our functions. And we're going to get plus here, minus here. X is going to be equal to 1. X is going to be equal to negative 2. So yes, somewhere over here, right, somewhere over here, they're going to intersect again, but we are looking in the first quadrant where x is positive, so the answer is going to be x equals 1. Okay, and then again, fundamental theorem of calculus is where we do for this problem. So I know that you guys can figure that out. And yeah, so that's going to be it for video number 2. We come back to video number 3. We're going to start talking about the fundamental theorem of calculus part 2. So I'll see you guys in the next video.